Okay, we're going to start off with some more practice conversion problems. And so we have 25 centimeters, and you're asked to find how many millimeters that is. So write down what you want to convert, which is 25 centimeters. You're going to multiply it by a conversion factor, which 10 millimeters is 1 centimeter. Make sure your units do cancel, so centimeters will cancel. And then your answer is going to be 250 millimeters. Okay? And then on our next one, you are asked to convert 150 millimeters to centimeters. So again, we're going to write down our 150 millimeters. We're going to look up our conversion, and we have 1 centimeter is 10 millimeters. Now notice how the orientation of this conversion factor is the exact opposite of the previous one, because here I have to convert my millimeters. So when I do the math, my answer will come out to be 15 centimeters, because that is the only units I have left. Okay, let's do a few more. So in this question, we have a speedometer on your car reads 40 miles per hour. So we have 40 miles per hour. I'm going to write that down because that's what we're wanting to convert. And we want to know how fast are you going in feet per second. So we look at our conversion sheet and we see that there's 5,280 feet in 1 mile. Okay. And we know in 1 hour there are 60 minutes. And we know in 1 minute there are 60 seconds. So let's check our units if they're going to convert. So miles are going to go away, our hours will go away, and our minutes will go away. So the only units we're left with are feet per second. So what you're going to do, you're going to take 40 times 5,280, and you're going to divide that answer by 60 times 60. Now, your final answer will be 59 feet per second. So what you want to get used to using on your calculator, you should have parenthesis button. So in this problem, the way I would input it into your calculator, you would take 40 times 5,280 equals, and then you would say divided by, open parentheses, 60 times 60, close parentheses, and equals. That way you're telling the calculator that you need to do 40 times 5280 and divide that value by 60 times 60, not just by 60. Okay, the next one we want to try, we have a TV screen that has a width of 24 inches. So 24 inches is going to be what I'm going to convert, and we want to know what is its width in meters. So we know in 1 meter we have 39.4 inches. So here again, always check to make sure your units cancel. Inches cancel. Only units I'm left with are meters. Plug it into your calculator and you should get 61 meters. Okay. Joe is 74 inches tall. So we write that first. What is his height in centimeters? Well, we know in 1 inch we have 2.54 centimeters. So our inches are going to cancel. Our only units are centimeters. So we have 187.96 centimeters. And then our last practice conversion we want to do, how many seconds are there in a year? So we start off with our year, and we have to convert it to seconds. So we know we have 365 days in 1 year. We know that we have 24 hours in 1 day. We know we have 60 minutes in 1 hour, and we know we have 60 seconds in 1 minute. So let's check our units. The years are going to cancel, the days will cancel, the hours will cancel, and the minutes will cancel. So the only unit you're left with is seconds. And it's going to be a big number. So we have 3153600 seconds. And the next part of the notes, I'm going to show you how you would write that into a smaller quantity. Okay? So that gives you some practice on converting units. Now let's go back to our PowerPoint and talk about significant. So we're going to try to adhere to significant figures in class. It's always a problem sometimes to make sure we follow significant figures, because I sometimes get a little lazy and I don't always do it, but I'm hoping to be better off this semester. So a significant figure is just a method of expressing numbers properly. We have rules for multiplication and division and addition and subtraction. So when you're multiplying and dividing, you want to leave as many significant figures in the answer as there are in the quantity with the least number of significant figures. Okay? When adding and subtracting, you're going to leave the same number of decimal places in your answer as there are in the quantity with the least number of significant figures. So the first example is a division. So we have 6.8 divided by 1.67. Well, the smallest number of significant figures is 2, which is 6.8. So therefore your answer should only have 2 numbers, 2 significant figures. In the second example, you're adding those 2 together, and our rule for that says you want to leave the same number of decimal places in the answer in the quantity with the least number of significant places. So you have one that has 0.1 right behind the decimal and one that has 2 decimal places. So the least would be the 1 decimal place. So your answer is going to be 6.5. There are rules that we can follow to help us along with this. And these bullet points are the rules. So the first rule tells you digits 1 through 9 are inclusive. They always count as significant figures. So any number from 1 to 9 is going to be significant. So in this example, 14.232, you have 5 significant figures. Next, we're told that leading zeros are not significant. Leading zeros or zeros in front of the digits 1 through 9, inclusive. So in this example, you have 0.00045. So all the zeros in front of that 4 would not be significant. So you'd only have 2 significant figures. Then you're told that confined zeros always count as significant. Well, confined zeros are going to be those zeros between the digits 1 through 9 inclusive. So here we have 2 zeros in between the 6 and the 7. So the total number of significant figures would be 4. Then we're told that trailing zeros are only significant if there's an overbar or a decimal point in the number. Well, our first example shows us a decimal point, so therefore we have 4 significant figures. The second example shows us that we have an overbar. See that little line on top of the last 3 zeros? That's what's called an overbar. So in that case, we have 4 significant figures, because remember the 0 in front of the 2 is a leading 0, and that would not be significant. So also significant would be an exact number of people. Okay. Now, when we determine the allowed number of significant figures, you're typically going to have to round, okay, in order to get that exact number of significant figures. So anything less than 5, we drop it. Anything 5 or greater, you're going to round up. So this first example, if you want to round to 3 significant figures, then you would round it up to 26.1 because it is less than 5. The second example, when you're rounding to 3 significant figures, because the 6 is 5 or greater, then your 3 significant figures would be 10.1. Okay. So in this next example, we're going to be rounding off to 2 significant figures. So we know the leading zeros are not significant, so when we round up this number to 2 significant figures, we would get 0.10. Now this next problem, you're asked to do the calculation and then round the answer to 2 significant figures. So your answer comes out to 1780, which is actually 3 significant figures, because remember, the 0 at the end is only significant if it's an overbar or if it has a decimal place, and this one has neither. So to round it to 2 significant figures, you would actually have to round it up to 1800 because of that 1780, 80 being greater than 5. Okay, we're going to stop this part, and then we will start up our next section with some practicing on significant